Okay, here we are. In case you can't see or can see, we're near the county complex at a bit of a road cut. This is for Lab 10. Now, part of the reason for Lab 10 is to try to give you guys a little bit of a taste of actually applying what we've been learning in class this semester, or online because of the virus for much of the last 6 weeks, in the field and actually putting your knowledge to use. So this is an outcrop here. Now, typically speaking, when we're in the field, this is sometimes as good as it gets. Sometimes it's even worse. So we don't really get really good outcrops all the time. We have to make do with what we can find. Now, part of the reason we're out here today is a little bit of an introduction to field methods. Field methods is the things that we do in the field, the observations, the measurements we make. We've talked about some of this already. We're going to kind of go into it a little more detail. So, one of the things that you're going to have to do for Lab 10 is I need you to make a quote-unquote field sketch. That is a drawing that basically takes into account what the outcrop looks like. It doesn't have to be very detailed. You do not need to be photorealistic. You want to capture the essence of it. Generally speaking, this is going to go with your field description of the outcrop, describing the rock, what you notice about it. For example, you can notice things like there are layers in it that have cobbles, pebbles, boulders that do show some degree of graded bedding. Every once in a while, you have other layers that maybe have crossing bedding in them. You've got layers that are made of finer material, layers that are made of coarser material. What color is it? So forth and so on. Now, this you can probably do off the video, though I would really recommend you come out here to the site to look at it in terms of exactly where we're at. That's the road there up to the county complex, just after the curve. If I walk over here without falling, there we go. You can see the complex a little better, and down there is a McDonald's and Safeway. So, now the idea of the description is simply to provide enough detail so that when somebody else follows in your footprints, months, years, decades later, they understand that they're looking at the same outcrop you did. So they can recognize the same outcrop. The same is true for you when you're mapping. You want to have enough detail so that you can recognize this outcrop as being the same material if you encounter it at another location. Now, one of the other things that I want you to do that we would normally do as a group is actually do a strike and dip on the outcrop. If I back up, hopefully you notice that the layers look tilted, and that's because they are. So we can measure a strike and dip on this. Now, some of those layers are good bedding planes, some of them are not. It's a matter of trying to figure out which one's the best. And I'm going to go through this process for you guys. You're responsible for getting the information out of the video and figuring out what the strike and dip are as I do the process. Now, how do we do that? Well, first and foremost, we need a tool called a Brunton compass. This is a Brunton compass. Hopefully this is focusing. You'll notice that it's a little weird that the east is on the left-hand side, west is on the right-hand side. This is so we can take measurements without having to do the flip in our head. This particular version of the compass is a 360 compass, meaning that it goes from 0 to 360 degrees. You can see that it has two levels, a bullseye level and a bar level. It has this little button here for stopping the free arm that has the magnetic compass part on it, and then it has a clinometer on the back bottom that allows us to measure strike. So I'm going to put this down. I'm going to go through this process. Hopefully it stays in focus. I'm working with my GoPro. I've never done a video like this, so we'll see what happens. All right. Hopefully you guys can see the outcrop. So sometimes when we're doing this, one of the things that we need is a good flat surface. Now, this is one I've chosen because right in here is a fairly good surface. Looks like a bedding plane to me. So you can see that it's not quite perfectly level. This is why we can sometimes use something. In this case, I'm going to use my iPad cover, which is relatively flat on both sides and parallel on each side. You can use a map board, which is just a couple pieces of plexiglass that are taped together, or you can use a clipboard, assuming the clipboard doesn't have anything poking off the bottom of it that makes one end not sit flush. You can use this just by putting the flat surface down like that. Now, when we use the compass, we want to try to take the north end of the compass and keep it in the northern hemisphere of the area. North happens to be behind me, so we're going to leave this end pointing in that direction. To find the strike, we want to put this edge of the compass down on the outcrop or our flat surface, and then get the bullseye level, and then take the reading. So if we do that, I get to about there. And now I notice that, oh, my compass is pointing in the southern hemisphere, so I have to switch it around. All right, so I'm going to get it steady. And I am getting a reading of a strike. Once it settles down, 269 degrees. So that would be the strike. It's 269 degrees. We'll do the mathematical conversion on that in a moment. Now, if I had a pen or pencil, I can make a mark and then make it very simple to take the dip. Thankfully, I've left a mark in my cover. Now, the dip is always perpendicular to the strike. So we want to put the compass as close to perpendicular as possible and move the clinometer arm on the back until we get the bar level to center. And that's going to be about there. Now, one of the tricks of the trade that I find helps is rotating the compass at this point. If I rotate the compass and the bubble moves up the hill, that means I've not found the steepest angle on the strike, which means maybe my dip is, I haven't found the steepest angle on my dip, which means maybe my strike is off or my dip is off, and I have to check that. So if I run this like this, and in both cases, the bubble does not retreat uphill, so I can pull this off and read it. And I am reading that I am getting a dip of approximately 23.5 degrees in the southern direction. And I would keep that note also. So the strike of 269, another way to think of that is that could also be just about, so let's see, do that math. We end up being about 81 degrees east of north for this today. So that's basically doing the strike and dip. Now, Anybody want to find the error I made while doing that? I will give you extra credit for it, 5 points extra credit on this lap, because I made an error in my measurement. If you can tell me what it was, I'll give you those points. Okay? We'll add that in the write-up. I'll add that to the write-up for your quiz. Some of the things you can also look at in terms of this is how solid is the material, how is it weathering, what does it look like on the inside, if it's different, things of that nature. The fact that one of the things you can see here, there it is this material undergoes differential weathering, which is illustrated by this feature right here. Let's get stable footing. Illustrated by that feature right there. That's differential weathering. Now, it's not large scale, but it shows you how the rock, which is harder, is protecting the softer materials of the Nogales Formation underneath it. For the rest of this, I'll make a second video and I'll amend it here. We're going to walk up this way, around, and go to the walking trail that is on the county property here, and I'll have a different location for you guys to look at. All right, this is near the top of the trail. You can kind of see off in the distance there is the county complex, the roof of it. One of the things I wanted to mention while we're up here is something that you can see that's kind of interesting, and that is the appearance of the ocotillo here. Ocotillo is one of these plants that can behave kind of like an indicator to us. One of the things that's unusual about ocotillo is it likes a soil that has a bit of a calcium carbonate concentration to it. So when you have ocotillo occurring in nature, you tend to find it in soils that contain some degree of calcium carbonate, whether that is a limestone-based soil or it's a soil that's washed in this case, we're on top of some alluvial material that's been washed in on top of the Nogales Formation at this point, and there is some degree of broken up limestone in it apparently. So that's why we have this ocotillo here, and you can see it's relatively confined into certain areas. So that kind of gives you an idea of what the soil content may have. Okay, just up there at the top of the hill, I was talking about the ocotillo. You can still continue to see how it comes down through here. Again, this is just something of interest for you guys to know. Now, I'm going to walk down this way to the next mountain. And hopefully you guys can hear me. I don't know if I'm speaking loud enough to be over the wind, but hopefully I am. But the next outcrop is just right around the corner here. And it's again going to be the Nogales Formation, so we're dealing with the same material. But here we can see a difference in the way the bedding is. We see a little bit of a difference in the bedding structures. Let's see, which one is the better one today with the sun angle? Kind of make it out there. Can I make it out better here? Usually this is better seen with the morning sun. Okay, we can kind of make it out right there a little bit. It's probably going to be better on this upper one though in the shade, which is going to make it a little harder to see, but we will do our best to see it. So if we look at this bedding very, very carefully, one of the things that we note is we see that some of the layers are at angles to each other. Like down in here, you can kind of see how there's a layer kind of like this, layers like this. What we're seeing here is a type of bedding that's internal layers within the sediment itself. It's indicative of the way the material was transported, in this case in water, probably following some sort of asymmetrical ripple mark or dune-like structure, but fairly small. Hopefully you can figure out what type of bedding that is, because that's the question for this location, is what type of bedding can you see in this. Now, you may need to come out here and look at it. Again, I don't know if the video is of a good enough quality for you to be able to see this. If it isn't, coming out here to look at it might be better. Again, morning sun, which has this fully lit up, is usually better for this. That's why we tend to come out here in the mornings. But hopefully I've given you enough clues that you can figure it out from the video and from maybe walking out here if necessary. One final thing before I go, that's another extra credit opportunity I'm going to give you. Hopefully you know where City Hall is at for the city. There is an outcropping of the Nogales Formation at City Hall. Specifically, it's between the Chevron station and the City Hall. For extra credit, 10 points extra credit, go to the City Hall location. Look at that outcrop. You will find a series of faults in the outcrop. Your extra credit question is to tell me how many faults and the type. Are they reverse or normal, and how many are there? It's as simple as that. That's all you have to do. I'll put that into the quiz section for this lab, and hopefully, it's not the same as being out here. Hopefully this is virtual enough for you guys to do it. If necessary, feel free to come out here by yourself and look at this stuff. And with that, I'll talk to you guys later.